Hello students, welcome to Gnana Deeksha concept based digital learning. My name is Priyanka, working as trained graduate teacher in physical science at Telangana Social Welfare Residential School, Navipet at Nizamabad. Today in this session we will learn about what is buoyancy, factors on which buoyancy depends, Archimedes Principle and applications of Archimedes Principle of buoyancy in everyday life. So let me start my session with a story. The title of the story is Who Sank the Boat? Beside the sea, there lived a cow, a donkey, a sheep, a pig, and a tiny little mouse. They were good friends. One warm sunny morning, for no particular reason, they decided to go for a row in the bay. As you can see in the picture, first the cow enters the boat and the boat almost tilts one side and the cow gets scared. To balance the boat, next the donkey gets into the boat. You can observe the boat sinks a bit because of weight of cow and donkey. But they both feel relaxed and out of danger because the boat is stable now. Now it is the pig's turn to get into the boat, who was very much scared to leave the log, but it manages to get in. The boat starts tilting a bit to one side. Then the sheep enters the boat slowly and carefully. The boat sinks a bit deeper, but was floating as it is balanced by 4 animals on 4 sides, and all the animals were happy and feeling safe. The last one to enter the boat was the little mouse, and when the mouse enters into the boat, you can see what has happened. The boat has sunk completely into water because of weight of all animals. They all fell into water and they had to come out of water by swimming. So, who sank the boat? Is it the little mouse? You may be thinking why the boat has sunk. And you may be also wondering, the boat was taking the weight of heavy animals, but it sank when the little mouse, who is least in weight, got into the boat. So let's study the science involved in today's class. Let me start with an example. Take a mug filled with water in hand. When you hold the mug, you can feel the weight of the mug because gravitational force is acting on it. Now, as you can see in figure B, take a bucket filled with water and dip this mug in bucket of water. You will observe there is loss in weight of the mug. The mug filled with water feels lighter in the bucket of water than outside when you are holding it in the air. Why? Why there is loss in weight of the mug? It is because there is some force acting on the mug, which is the result we see decrease in weight of the mug. Then in which direction is this force acting? If we assume that the force which we are talking about is acting downwards, then we need to feel the weight of mug even inside the water, as gravitational force is also acting downwards. But as there is loss in weight, it means there is a force which is acting upwards. So we can conclude that the upward force and the gravitational force are acting in opposite direction. For example, we can experience this when we draw water from the well. The bucket feels light in water because upward force is acting on it. But as we lift it up, we can feel the weight of bucket when it is out of water. Now what is this upward force called? This upward force is called as buoyant force or upthrust. Now what is this thrust? The force acting on an object perpendicular to its surface is called as thrust. We all know force is push or pull of an object. So thrust is different name for force which is acting perpendicular to the surface. Let me explain it with a simple example. You can see the picture of notice board or a bulletin board. Now consider my left palm as the surface of notice board. If I want to keep any notice, I'll try to push the pin in perpendicular direction. So this is a surface and the force is acting in perpendicular direction, which is called as thrust. Let's take another example. Take an empty plastic bottle closed with cap. Now drop it in water. What happens? The bottle will float. Why is it floating? The bottle is floating because force is acting on the surface of the bottle from downwards. So this force we are calling as thrust. And since it is acting upwards, we are calling it as upthrust or buoyant force. So buoyancy guns or tells if objects float or sink in fluids. We can test this buoyant force by pushing the bottle into the water. Now try to hold the bottle and push it inside the water. You will feel the bottle is also exerting upward force on your hand. If you release the bottle, you will see the bottle will come up to the surface on its own. I think you can guess why. Now push the bottle more deeper and you can feel that more upward force is acting against your hand. And now when you release the bottle, it will rush back to the surface. It will come up faster to the surface than it came up in the previous case. So the upward force increases as it is pushed deeper into the water. And that's because the pressure also increases as we go deep into the water. Do liquids exert pressure? Let us see by doing an experiment. Yes, liquids have weight and they are stored in containers. They exert pressure on the base of container, that is downwards, and towards walls of container, that is sidewards, in which they are enclosed. We all know pressure is defined as force per unit area. The units of pressure are Newton per meter square or Pascal. So pressure is inversely proportional to area. It means if area increases, pressure decreases. If area decreases, pressure increases. Let me explain it with an example. The vegetable vendor who carries a basket on head, don't keep it directly on the head because it pains. Instead, he places a twisted cloth on the head to increase the area so that the pressure decreases and the weight of basket distributes uniformly on head. To prove liquids exert pressure, look at the first figure. We can derive something interesting if we divide bottle into 5 parts. The second layer takes the weight of first layer. The third layer takes the weight of second and first layer. The fourth layer takes the weight of the above 3 layers, and the fifth layer is taking the weight of all 4 layers. So, pressure at the bottom is more as it is holding all 4 layers. For example, we experience this when we do pyramids at school. So, the one who is standing at the bottom experiences more pressure as one upon him stands many people on him. So, how can we prove this? There is even a way to find it out. Make a hole at top layer of the water. It flows out with an angle. At second layer, it flows out with wider angle. And as you see down, its angle increases significantly. So we can conclude that pressure at the bottom is more than at the top as the angle is increasing significantly from top to bottom. So fluid pressure increases with depth and also buoyant force increases with increase in pressure. So in previous example we have seen bottle rushing up as buoyant force is acting on the bottle when it is pushed deeper. So do we observe this buoyant force in air? Yes, we observe buoyant force even in gases. Liquids and gases are together called as fluids. They are called as fluids as they have property to flow. So we have different layers in atmosphere. As you observe the picture, you can notice the number of air molecules are decreasing as we go up. As the number of air molecules decreases, the weight of air also decreases, and in turn the pressure also decreases. As you go down, the weight increases as the bottom layer of atmosphere with increase in number of molecules. So the pressure at the bottom layer is high and the buoyant force also increases with depth as we go down. So both liquids and gases exert buoyant force. So the empty bottle when you dropped in water was floating. Suppose if you fill the bottle with water and drop it in water, then what happens? The bottle will sink. Why? So let's discuss something interesting which tells us about sinking and floating, and also the magnitude of buoyancy depends upon which factor. The magnitude of buoyancy depends on important factor called density. So density plays a major role in determining the buoyant force exerted by the liquids. It also tells about sinking and floating of objects. So density is defined as mass per unit volume and its units are kg per meter cube. Simply, density is amount of mass present in given volume. If you observe picture, both volumes are same. But if you see the green part, you can observe it, M1 is occupying less area than M2. So simply we can say M2 is denser than M1. If you observe next figure of car parking, the parking place is same on both sides. But there are 3 cars on left side of parking and on the right side of parking place is full. So we can say the right side is densely parked with cars. Similarly, when you observe trees, there are many trees on one side and less on the other side of same area. So left side we can call it as dense forest. So we got to know about density. But how to know if object is floating or sinking based on density? For that, we need to know about other term which is relative density. Now, what is this relative density? The term relative means comparing. So, relative density is comparing density of one substance with another. So, we compare density of substance with density of water because we are putting them in water and trying to find out if they are floating or sinking in water. So, here water is taken as reference. So, relative density of substance is defined as density of substance by density of water. So, relative density tells us about how denser the substances are compared with water. And it also tells if substances or objects floats or sink in water. Since it is ratio of same quantity, that is density by density, both get cancelled, so it has no units. Do you know what is density of water? The density of water is 1000 kilograms per meter cube. So if you want to find out relative density of water, we have to compare its density by density of water. So it is simply density of water by density of water. So it is 1000 by 1000. So relative density of water is 1. So if you want to calculate relative density of silver and ice, as you can see in picture, we know density of silver is 10,500 kilograms per meter cube. So if we want to find the relative density of silver, it is density of silver by density of water. So it is 10,500 by 1000. Since both are densities, the units gets cancelled and we get 10.5 as relative density of silver. So if you want to find density of ice, it is 934. So if you want to find out relative density of ice, it is 934 divided by 1000. So we get relative density of ice is 0.934. So we all know relative density of water is 1. So if object's relative density is greater than 1, those objects sink in water. If object's relative density is less than 1, those objects float on water. So from above example, silver sinks in water as its relative density is 10.5, which is 10 times greater than relative density of water, which is 1. And ice floats on water and its relative density is 0.9, which is less than the relative density of water, which is 1. So what did we conclude? Objects whose relative density greater than 1 sinks in fluid and objects whose relative density is less than 1 floats on the fluids. So empty bottle and filled bottle have same volume but mass is different. So empty bottle is filled with air which decreases its density and make it to float, whereas the bottle filled with water sinks as its density increases. Then, do objects having same mass float or sink? So here we'll take two objects, say a wooden block and a metal pin of same mass. Let's assume they both have mass, say 1 kg. If you drop this wooden block and small metal pin of same mass, that is 1 kg into water, we observe that the pin has sunk and the wooden block is floating on the water, as you can see in the picture. Why? So you may be wondering why. Though both are having same mass, one is sinking and the other is floating. As we discussed, relative density of water is 1. So objects whose relative density is less than 1 float on water and relative density greater than 1 sink into water. So when we observe the wooden block, it is occupying more place, indicating the volume of wooden block is more. So the molecules in wooden blocks are arranged very far from each other, decreasing its density and making its density less than 1. The metal pin is occupying less place in water, indicating its volume is less. Means molecules in pin are tightly packed, which is increasing its density and decreasing volume, which makes its density greater than 1, though it is small. Then, large ships and the anchor, which is used to keep the ship stable without drifting away, are made of same metal. But ships float and the anchor sinks to the seabed. Why? An anchor is a device normally made of metal used to connect the vessel to the bed of the body to prevent the craft from drifting due to wind or current. The ships are made of iron and steel, and even the anchor which is used to stop the ships and keep them stable without drifting them away is also made of steel and iron. But large ships float and anchor reaches seabed. This is because of changing density. Ships occupy large volume and anchor occupies less volume in water. As we discussed in previous example, ship is floating because it has large volume like wooden block, and anchor is sinking because it has less volume like wind. So here ship's density is less than water and anchor's density is more than water. Then what is happening to water when objects are floating and sinking? So let us see what is happening to water when objects are sinking and floating by simple observation. So as you can see in the picture, take a graduated beaker filled with water up to some margin. So dip your index finger in water. You can observe water level rises slightly. Now dip both index and middle fingers. We can observe water level rises a bit more. If you dip all your fingers up to your wrist level, you can clearly observe there is significant rise in water level and the water started spilling out of the beaker. So what did you learn from this activity? When fingers are dipped in water, they are pushing the water aside. This is called as displacement. Displacing means to move. So fingers are taking place in water by pushing the water away. So the ancient Greek mathematician Archimedes observed something similar when he got into bathtub. Archimedes gets into bathtub every day to take bath, but that day something happened which made him to think about the displacing water. Let us know about it. The king of Syracuse had given a craftsman a certain amount of gold to make an exquisite crown. So, when he gives the crown, the king called Archimedes and asked him to find out if his golden crown is made of pure gold, but condition is without damaging it. Because the king suspected that the crown made was not of pure gold. It was a big task for Archimedes to find out the purity of gold without damaging it. He cannot melt it down into a regular shaped body in order to calculate its density. So he thinks all day and night. Next day, when he enters into his bathtub to take bath, he observes the level of water rises as he gets into the tub and the water falling out of the tub. Then an idea struck to his mind and he realized that this effect can be used to determine the volume of the crown. So Archimedes planned to submerge the crown in water and he noted that the submerged crown would displace the water equal to its own volume. So by dividing the mass of the crown and the volume of the water displaced, the density of the crown can be known. As we know, density is defined as mass per unit volume. He can also find out the density of crown by taking same mass of pure gold and submerge both of them in water. If they both displace same amount of water, then the crown is made of pure gold. But if crown displaces more water, then it is alloyed with some other cheap metal which lowers its density. So next, Archimedes then went to the streets naked so excited by his discovery that he had forgotten to press crying Eureka, Eureka, meaning I have found it. Later, he gave a principle, Archimedes Principle, which says when an object is immersed fully or partially in a fluid, the upward force applied by the fluid on the object is same as the weight of the fluid displaced by the object. So let me take a simple example to make you understand this clearly. So as you can see in the picture, take a solid object of mass 5 kg and suspend it on a spring balance. The balance will weigh 5 kgs. So let this be first case. For the second case, take a beaker with small opening at the top and fill the water in the beaker right up to this opening and keep a small container near the outlet of the opening as shown in figure A. Now as shown in figure B, slowly lower the solid object into the water. We observe that the reading in the balance is decreased compared to the previous case. Why this has happened? This is because of buoyant force acting on the object. You will also notice some water has displaced and got collected in small container. Now in this case, we can say the weight of this displaced water is equal to the magnitude of buoyant force acting on the object. So 2 kg is a buoyant force acting on the object. If we weigh the water, we get 2 kg. So it means the object weighs only 3 kgs in water. So the last 2 kg is a buoyant force acting on the object. So if displaced water weight is equal to the weight of the object, then the object floats. If not, it sinks because gravitational force will be more in this case. If object displaces 5 kg water, which is equal to its weight, then the objects will float. Since it is displacing only 2 kg water, which is less than its own weight, it sinks into water. So, we need to keep in mind two important things. Buoyant force depends on density of objects. Objects with less density experience more buoyant force and displaces more water. Objects with more density experience less buoyant force and displaces less water. So, where can we apply this Archimedes principle? So, let us see and discuss few applications of Archimedes principle of buoyancy. So, if we try to swim, we use the principle of buoyancy here. Floating of ships and boats, and also how the submarines run in water, and also while doing scuba diving. Coming to air, we use buoyancy while flying the kites, while our birds and insects fly with the help of this buoyant force, and even the hot air balloons, and also during the skydiving. So the best example for the application of Archimedes principle of buoyancy is floating of ships. Now let us look at the figure and let us remind the story I introduced my class with. Let's relate this picture with our story. Consider the yellow shaded region as the boat. When cow entered the boat sank with inside. That is the yellow shaded part of the boat which is inside the water, and the black portion is a part of boat which is above water. As you can see the red arrow, it indicates the weight of boat with cow pulling downwards, and the blue arrow indicates buoyant force acting upwards by displacing the water equal to the weight of boat and cow. Since both are equal and acting in opposite direction, this makes the boat to float. The second figure indicates when other two animals, that is donkey and pig, got into the boat. The weight has increased. The boat has sunk deeper. This more yellow shaded part is inside the water, but still both arrows are balanced. More buoyant force is acting, which is equal to the weight of cow, donkey and pig by displacing more water and keeping the boat afloat. Figure 3, sheep enters the boat now. The weight has increased. The boat is almost inside water, that is the yellow shaded portion, but still it is floating because as weight is increasing, the buoyant force is also adjusting and trying to displace more water equal to the weight of 4 animals. When you observe the figure 4, this is the case when the little mouse entered the boat. The weight has increased bit though, but When the boat went little deeper, the water entered the boat, increasing its weight. Now the buoyant force could not adjust itself and is unable to produce the upthrust to counterbalance the weight of all animals together, and it has sunk. Then how do large ships float? Yes, let us see applications now here. The ships can stay afloat by displacing weight of sea water equal to its own weight. The ship will sink to a certain level until its weight is equal to the buoyant force. For example, if a ship weighs 1000 kg, then it has to displace the water. If we weigh, the volume of water should be equal to 1000 kg to make it float on water. Then how we can do it? How it can be done? How the ships are able to float? The ship's body or the bottom frame of ship, as you can see in the picture, the grey shaded part, it is called as hull, which is made hollow for the air to fill in. This decreases the density of ship, which makes its density. How it can be done? The bottom frame or body of ship is called as hull, which is made hollow for the air to fill in, and how it can be done? The bottom frame or body of ship is called as hull, which is made hollow for the air to fill in, and this decreases the density of ship, which makes it less than the density of fluid in which it is immersed, and also allowing more buoyant force to act on it, which displaces the water equal to the weight of ship. The density of sea water changes from place to place. Sea water and freshwater densities are different. So, all heavy loaded ships have a plimsoll line, that is, several indicator lines are marked on it, as you can see in the picture, to check the safe depth of ship to navigate it different types of water. So, based on this plimsoll line, the loading is done on the ships and check the safe sinking depth of the ships to avoid the water entering into the ship and avoid complete submerging of the ship. So, next application is submarines. Submarines are a special type of watercrafts that can operate under water. They are typically large vessels with a high number of crew. Nuclear submarines may have a crew over 100. Submarines are used by the military as a part of Navy forces, protecting aircraft carriers and carrying out other tasks. Some submarines can remain submerged for months at a time. Submarines have large ballast tanks to control its position in the depth. It can submerge below sea level. When afloat, as you can see in picture, water is removed from ballast tanks so that it is filled with air and reduces its weight and produces large buoyant force. When submarine is submerged, ballast tanks are filled with water again, which increases the weight of it, and then it gets submerged to a depth where buoyant force is equal to its own weight. Next application is while swimming and floating. How we can swim? While swimming, we will move our hands and legs. While doing so, we are trying to push the water away. So this displacing water equal to a weight of our body keeps ourselves floating on water. This displaced water creates buoyant force equal to the weight of our body, not allowing us to sink. We can remain floating by inhaling more air first and exhaling less air outside. Our lungs, when filled with air, decreases the density of our body compared to the water and allows us to float. Let us discuss few examples of how buoyant force is exerted in gases. When a hot air balloon is filled with gas of lower density than air, such as hydrogen, helium, or hot air, its weight decreases. The balloon experiences a buoyant force. If buoyant force is equal to the total weight of the balloon, it will remain stationary in air or continues to move upwards with constant velocity. If buoyant force is greater than the total weight of the balloon, it will be accelerated upwards. Next application, how do birds, insects and kites fly in the air? Birds and insects, when they flap their wings down, they push the air down. They are displacing the air downwards so that equal and opposite buoyant force can act on it to lift them in the air. Sometimes they are steady and keep flying in the air and they don't flap their wings. It is because The buoyant force acting from downwards is equal to the weight of their body and keep them moving in air. If they have any injury in wings and can't fly properly, they fall down because in this case they are unable to displace air equal to their body weight. So buoyant force exerted will be less and the gravitational force will be more. That's why they fall on the ground. Similarly, kites also fly in the same way. We pull our hand down frequently while flying the kites. We do this so in order to displace air equal to the weight of kite. If displaced air is less, then kites fly to the ground. So these are the few examples of applications of buoyant force. You can collect information on some more examples. So what are the key points? Let me discuss once again for you. So let us discuss the key points what we discussed till now. An object immersed in fluids experiences buoyancy, and this is the result of loss in weight of objects in fluids. Loss in weight of objects is determined by the buoyant force acting on them. Buoyancy depends on density. Magnitude of buoyancy acting on an object can be known by the amount of fluid it displaces. Floating and sinking can be decided based on its relative density. Densities can be changed by varying the volume occupied by objects having certain mass. Less dense objects displaces more water, indicating more buoyant force is acting on them and they try to float. More dense objects displace less water, indicating less buoyant force is acting on them and they sink. Thank you.